charging. Nope. All right, so exponents. We're going to go through the beginning of this worksheet. Make sure you have your worksheet. Make sure you're showing your work. How many of you remember exponents and how to simplify exponents? Good. You should have seen them at least once, probably twice. Since 5th grade, you should have at least seen them twice. But I wanted to go over them again to make sure we have a good understanding of them. So, in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For example, if I have 4 times 4 times 4, that took a lot to write. You can rewrite that as 4. How many 4s are there?
3.
So 4 to the power of 3, which just means 4 times 4 times 4. Okay? There are different parts to this. I'm going to write it bigger so I can label it. 4 to the power of 3. What is the big number called? Does anybody remember the vocab word? It is a whole number in this case, but it's not always going to be a whole number. Anybody have a good wild guess? Take a wild guess. Starts with a B.
Base.
Yes. So the big number is called the base. Okay, so the base number, or the number you're multiplying it times itself, is called the base. Now, what is the little tiny number up top called? I was going to say you should know that one because that's the title of the lesson. Okay, the little number is called the exponent. Okay, so you should have been able to fill out the 2 fill in the blanks on the paper at the top where it says base and exponent. And then how would I read this? The 4 and the 3. How would I read that if I were to read it out loud to you? What would I say?
4 to the power of 3.
4 to the power of 3. 4 to, write this in a sentence underneath. Right underneath the word base. 4 to the power of 3. Okay, that's one way to say it. There is another way to say it. Does anybody know the other way to say it? There's always 2 ways to say it. This is slightly easier to remember. It would be 4 to the 3rd power. Okay, so that's the other way. 4 to the 3rd power. All right, this right here, this is called expanded notation. This is all going in your journals, guys. Everything you see on the board needs to be written in your journal as notes. Expanded notation. Okay, and then this is called the exponential expression, the 4 to the power of 3. I'm just giving you the vocab word, exponential expression. Okay, and then if I were to solve this, what is 4 times 4 times 4? Go, calculator, go.
12.
No, not 4 times 3. 4 times 4, which would be 16, and then 16 times 4 would be 64. Or if you think it out loud, you can usually get to it. Okay, and then this last one is called the value, or the solution. All right, any questions on any of this? I know I gave you a lot of vocab words, but trust me, it's going to help you. I'm going to wait. Has everybody got it written? I'm going to clear the screen as soon as everybody has it. Got it? Nobody's yelling? I'm moving on. Oh. All right. So let's do number 1. Now, this is having you write it in 3 different forms, or has it got some of the forms already? Let's see, let me get what yours. I have the answer key in front of me. Okay, so it has the very first form written for you. It has the expanded notation, so you don't have to write the expanded notation. So our first one is 11 times 11. So how would I write that in exponential form? Thank you for raising your hand, Julie. What did you say? 11 to the power of 2. Say the whole phrase. 11 to the power of 2. And then the value, you would do the math. So what is 11 times 11? 121. All right, let me borrow somebody's calculator. I'm going to show you how to do this on the calculator. So I'm going to scoot with Julie for a second. Okay, so on this scientific calculator, there's a button that has an arrow that's going up. It kind of looks like this. That's it. That's all that's on it. It's on the... So that's one way to do an exponent. So I could say, on this case, 11, hit that button, 2. That means 11 to the power of 2. Okay, so that'll get you 121. I want everybody to do this. Practice this on your calculator. Where's your calculators? So scoot over with Julie so you can see. Okay. The other way, you see the button on there that has x to the power of 2? Okay, so that's if you are squaring it. So that's just going to work with the power of 2. So in this case, you would put 11 and then hit that x to the power of 2 button and then hit enter. And you'll still get 121.
For the value, do you want it in the...
Wait, what?
The little lines, what is it called?
Absolute value lines?
Yeah.
No, the 121 is the answer.
Wait, how'd you do this?
Those aren't absolute value lines. That's 1, 2, 1.
11.
11, and then if it's to the power of 2, you just hit that button and you see it squared it. And
I've done
then,
that before.
but that only works if you're squaring it. If you got to do the power of 3 or the power of 4 or the power of 15, then you have to hit the little arrow one. So I tend to just always use the arrow one because it makes my brain remember it.
Upside down looking symbol is actually called a caret. C-A-R-A-T.
This one?
And, yeah.
Oh.
Yeah.
This is called a carrot?
Just a kind of sheep.
Yeah, C-A-R-A-T, I'm pretty sure.
Oh, like a carrot of gold almost. Interesting. I learned something new today. Excellent. Thank you, Liam.
Thank you, Liam.
All right. Any other questions on how to do exponents on your calculator? Now, when we move things, I'm just going to give you a little tidbit. When we move things back and forth across the equal sign, we do the opposite math, right? So if it's add, we subtract. If it's subtract, we add. If it's divide, we multiply. If it's multiply, we divide, correct?
Yes.
If it's an exponent, what would be the opposite of doing the exponent? Does anybody know? I know, this is a trick. Square root. So if I want to get rid of this 2 without doing the math, I square root. You're not going to do that today. I just want to give you a preview. If it was like 9 to the power of 3, you would root it whatever the power is to get rid of it.
Wait, why
Wait,
do you want to
can you
get rid of it?
explain what that means? Like,
So-
what it is?
So for the 11 to the power of 2, you square root it, so it'd be
Right, let me give you a better example. So if I have 11 to the power of 2 equals, I don't know, 2a, and I'm trying to get this 2 over here for some reason, which you're not, but just bear with me. To move the 2, you square root it. And then whatever you do to one side, you do to the other. So I would square root that side.
What does that mean?
Doesn't make sense to do it here, but you'll get to this at some point. I just wanted to show you what the opposite of square root is. And then if it was 9 to the power of 3 equals 120. Wow, cool. 127, to move this 3, you would cube root it. So you do the cube root of it. Which there's a button on your calculator to help you do that. Question?
Why would we want to move it like that?
So the reason you want to move it is you may eventually get to a to the power of 3 equals 127. And we're solving for a.
Oh, it's because you're putting it on a number. That's why I got confused.
I was just trying to show you the opposite of the sign. I should have done the letter to begin with. It makes more sense.
You keep saying square root, but like I don't understand what that means.
Okay,
Like you just put the symbol over it and then that's
so that's doing the okay, let me show you. So if I have 2 times a equals 10. To get a by itself, this is multiply, so we do division, right? And you get a equals 5. So in a to the power of 2, to solve for a, I have to move this 2 somehow. We can't multiply, divide, add, or subtract because it's exponents. So we do the square root. That's what this symbol is called, square root. Square root of both sides. So then this would become just a because the square root and the 2 cancel, and then you would have the square root of 10. If you could simplify that, which you can, but it's tricky, then you would do that.
And then is that your final answer?
It can be, a lot of times. If this can be simplified, you would simplify it. So like if this was 25, the square root of 25 is 5. But we're going to get to that later. I just wanted you to know that the opposite of a power is the square root sign. That's what I wanted you to know today. Okay? We will get to that in a later lesson. I just wanted you to have a little bit of an idea. Okay, so let's do the second one. Number 2. We have, wow.
1, 2, 3, 4, 6, 7.
All right, so there's a lot of 2's. How many 2's are there? 7. So I'm going to write this. What's my base number? 2. What's my exponent?
7.
Excellent. So on your calculator, do 2 to the power of 7. Is it?
Oh my, good job.
128.
Excellent job. So there's the answer to number 2.
A little late, but it's okay.
You still got there.
Well, I literally said.
All right. You see number 3, it's negative 5. How many times?
4. 4 times.
18.
Wow. That 5 got weirder. Okay, what is my base number?
5.
Negative 5.
Yeah, don't forget the negative. Negative 5
To
to the power of what?
4.
Why is my negative 5 in parentheses?
Because to know it's a negative.
It is helpful to know it's a negative.
So we can change it?
No, but I like where your head is. So when you put it, let's do this on your calculators real quick. Go ahead, Bella.
Because it's not solved yet.
Yeah, that's probably the closest to the right answer. Very good. So let's do this on your calculator. Everybody do this on your calculator. Negative 5 to the power of 4 like that on your calculator. Don't put parentheses.
625.
Ooh, 625.
625.
Is it positive or negative?
Negative.
Okay, now put it in parentheses and do it again.
Oh. 625.
625. Okay, so the difference comes in with the sign. When you have it in parentheses, it's like saying negative times negative times negative times negative. Well, these two make it a positive, these two make it a positive, and a positive times a positive makes your answer positive. Okay? This one, you would do the exponent part first, and then just plug in the negative on the end of it. So it is very important you pay attention to parentheses when you're dealing with negative numbers and exponents, okay? So if it has a parentheses, put it on there. If you are adding putting an exponent on a number that's already negative, put it in parentheses. So if I came in and it said negative 5, and then all of a sudden I was going to make it to the exponent, add those to it.
Even if there's not.
Right. To make sure you get the right answer. Otherwise, you're going to come out with a negative when it should be a positive or a positive when it should be a negative. So pay attention to that. Okay? Because it will make a difference. Fortunately, it's only half a point when I grade it, but make sure you have that. All right. Number 4, it's the same thing, just a fraction. I'm not going to do that for you. Let's skip down to number 6. Make sure you guys go back and do the ones I skipped. Some of you did not on one of your assignments.
Wait, are we supposed to do this on our notebook?
No, this is on your paper.
All we did was the example.
We only did the one example, yeah. Julie.
So for number 3, the answer would be the non-negative one.
Correct. Because it was in parentheses. All right, so 4 and 5, you can go do, well, let's do 5. Just kidding. Let's do 5. That's the first time. So we have 7 times 7 times 4 times 4 times 4.
Yeah.
Okay, so I have, how many numbers will be my base numbers?
2.
2. So I'm going to have what? 7 to the power of
2.
times
4 to the power of 3.
4 to the power of 3. And then now we can do the math. What is 7 to the power of 2?
49.
Huh?
49.
Oh, I heard 45. I was like, no. And what is 4 to the power of 3?
64.
Very good. And then your last step, what's 49 times 64?
3,136.
And that's all the work you need to show me. I don't need to, you don't have to go into crazy extra work. Just those steps. Any questions?
Where do we put the second part? Because there's only like 2 little boxes.
On your separate piece of paper where you're showing your work on. All you're showing me in the boxes is this and this. The rest of it should be on a separate piece of paper showing me your work.
Did we need an extra sheet for the rest of them?
Yes.
That we already did?
No, not for the ones we already did. You need to show me from about 5 down your work.
Wait.
Oh, look at number 8.
We're going to do
Oh,
it.
that hurt my brain.
That's the one we're going to do next. Okay, everybody got this?
Yeah.
Wait, I thought you said it also did 6.
No, because 6 is just like 5. It's just 1's a negative, so you can do that one. All right.
Oh, that hurt my brain.
Wait, didn't we make
So we have A times.
8 is that? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Look at the top left drawer. All right. We have, what is my base number?
8.
A. Very good. What is my exponent? How many A's are there?
9.
A to the power of 9. That looks like an A. A to the power of 9. Okay, is there anything else to simplify? No. So you're done. Woo.
That's it?
So you don't know the value, so you would leave the value blank.
Oh, you just leave it blank.
Yep, just leave it blank.
I want to smell
All right, let's look at number 9.
Wait, no, look at number. So for number 8, what would we write in the value?
Anybody else want to tell her what I said?
Nothing.
Nothing. You don't know it. You leave it blank. I did say that twice. No. Just need to listen. All right, so what would be my base number for this one?
XY.
XY.
Wait, what?
And then what would be my...
5.
Okay. Do I need to put anything else here?
No.
Are you sure? Take a guess.
I don't think
My hesitation should be telling you something.
So you're supposed to put something.
Yes, there's something else needed to make this a correct answer. Take a wild guess. Chloe? Nope. I like your...
Let's go with EMC. Parentheses.
Ah.
Yeah, because here's the thing is y is it looks like y on its own is
Yes.
power 5. Because if we make sure that x and y are together,
Yes.
then that will actually be a correct answer.
Correct. You need to add parentheses when you have 2 letters. Kind of think of it like the negative sign.
Thinking EMC.
Good job. Yeah, he's right. If I had x and then y to the 5th, then it's only applying here,
Yeah.
the exponent. So you have to put in parentheses. If you have it in parentheses, then this applies to this and to this. I could write it like x to the power of 5, y to the power of 5. That would also be correct. Okay, so the parentheses mean that exponent applies to both, which it does, because how many of these do we have? We have 5 of each, right?
Because the reason x to the power of 5 times y to the power of 5 is also correct is because xy is actually x times y.
Correct.
So you could technically write xy to the power of 5 as x times x times x times x times x times
Yeah.
y times y times y times y
Yes,
times
you
y.
could separate those out. He's saying I could go and then put the y's. Because it's all multiplication, so you can rearrange things. Which is also why you could get x to the power of 5 times y to the power of 5. Which we did earlier, right? We had a 7 and a 4. Same idea. And then, so fun to look at if I had, how do we write that? 7 to the power of, I'm not going to get into that yet because you'll have that in a more difficult lesson later. I like exponents, so I get nerdy about this one. Any questions on this?
So is the value the one with the parentheses?
No, the value, you can leave blank again. So the value is always going to be a number answer, meaning I've solved it all the way to a number. If you're left with letters and exponents, then you're just at the exponential expression. And that's fine. If you were to get to this, xy to the 5, and then, ooh, that's not right. And then I were to tell you x equals 2, y equals 3, then you could solve it. But we're not doing that right now. Okay, so number 10, same thing, you just have 3 different letters. Y'all can handle that, right?
Yes.
Number 12, you have numbers and letters. Do you want me to do one of those, 11 or 12?
Yeah.
Which one?
12.
12? I heard 12 first.
Yeah, 12.
All right. Okay, so how many base numbers am I going to have here? 3. Is he right? Yes. What's my first base number?
Negative 7 in parentheses.
Excellent. What's my next base number? And what's my last base number? All right, how many negative 7s are there?
2.
So to the power of 2. How many m's are there?
3.
To the power of 3. And how many n's?
2.
2. Now, can I simplify this any further?
With the negative.
Yeah, I can simplify this, right? What is negative 7 times negative 7? Positive 49, right? And then times m to the 3 times n to the 2. Now this answer would be considered a value answer because I have simplified it as far as I can. So that would go in your final box on the right. So for number 11, you'll have a value answer as well.
For number 12 then, what was the exponential expression? Just the
This
top.
one.
Okay.
That's your exponential expression. Good question. So for number 13, you will not have a value answer. And 14 you will. We'll do number 13 and 14 because they look tricky. Everybody got this one? Okay. Number 13. We have p minus 2 times p minus 2 minus 2. All right, what would be my base number? P minus 2, right? In parentheses?
Yes.
Yes. How many of these do I have?
3.
So that's your exponential form. Can I solve that? Not really. There is a simplification you can do, but it's not any better than what I'm looking at, so you can end it here.
Okay.
Could I apply this to this and this to this? Sure, I could say p to the 3, negative 2 to the 3, and simplify that. But this is considered a correct answer, so you can just stop there. Because this would simplify further. What's negative 2 to the power of 3? Negative 6?
Oh, wait, no.
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 That's not right. What would it be? Negative 2 times negative 2 would be 4. And then 4 times negative 2 would be negative 8. So this would be completely simplified. But I'm okay with this being your final answer for now. Eventually we're going to get to this point. But baby steps. Any questions on number 13? Okay, let's do number 14. And that's a 6, not a B, for those of you who think my handwriting is not great. All right, how many base numbers are we going to have? 2. Which was our first one?
A plus B in parentheses.
Very good. How many of those do we have?
To the power of 2.
And then what's our next base number?
6.
6. And how many of those do we have?
3.
Okay, so there's your exponential form. Can I simplify this?
Yes.
Yeah, because I can do the 6 to the power of 3. What is 6 to the power of 3? 216.
16.
Correct. 6 times 6 is 36, times 6 is 216. Now, always put your, when you're doing multiplication, always put your whole number first. So then I'm going to write this a to the b plus b after it to the power of 2. So this would be the correct value answer. Could I also write it like that? Yes, because all I did was distribute the exponent into my parentheses. So this is also correct. In fact, that's a little bit better of an answer, but I would accept either one of those answers. Questions? Because this is your assignment. So you need to go back and do, what, 5 problems that we didn't do on this example? 4. And then you need to do the back side.
Oh, wait, no, it is.
Does anybody feel like they need me to do any of the ones we skipped? I can. Do you want me to do any of the ones we skipped? Or do you feel good? Say one. Number 7? If you are good and you don't need any more examples, go. Number 7, we have 2 over 3. Is that right? Okay, so how many bases do I have here, Lexi? 2. So one of them is 2/3. How many of those do I have?
2.
Yep, so I put a little 2. And then my other base number would be?
2.
The base number, the big number, would be what I'm looking at.
9.
So it'd be 9.
Oh, yeah.
And then how many of those do I have? There. Okay, and then you would simplify this further by doing the math. So on your calculator, you do 2/3 to the power of 2. That'd be 4, 9, 3 times 3 is 9ths. And then what's 9 times 9?
81.
81. And then you would do 4/9 times 81.
Wait, why is there a line under the 9?
Under the 9. Oh, I was just showing Lexi what numbers I was looking at. So now you do 4/9 times 81 and you get
36.
36. All right. Anybody want me to do any other examples, or do you feel like you got it?
The exponential value is
This one.
I was like, because there's no exponent.
Yeah, this is the exponential value, and then this is me solving it to the answer. All right, go.